Hello, everyone. Good morning. Hope everyone is doing great. Right. So we
Good
have
morning,
Sir,
sir.
good morning. Good morning. So let me share my screen right away, and then we'll start. So this is 7th of October. Right. So people, we were starting this chapter. We started this chapter GOC, right? General Organic Chemistry. So I thought maybe if you can just quickly go through what and all we saw last class, and then it will be very useful, right? Okay. Okay. So we understood that this particular chapter can be divided into two parts. First part talks about where is it? First part talks about, okay, these are all are why we are studying about this carbon, right? Now, I told you that this IUPAC naming and isomerism comes under part one, and the electron displacement effects and the intermediates, right, will come under part two. We'll see it later, right? So in IUPAC naming, all you have to understand is they can give the structure differently. They can give it like this, or they don't give you the molecular formula. If they give you the molecular formula alone, obviously you will not be able to write the structure properly, right? They have to give the structural formula, right? A structural formula we can write like this, right? I told you to remember the terminal carbon atoms would be CH3, all the middle carbon atoms would be CH2, right? And if at all you are going to replace anything, all you're going to replace is hydrogen, right, from the carbons, right? Here, if you want, it will become CH2OH. Here, if you want, it will become CHOH, right? If you make a double bond, this will become CH double bond CH2, right? And then we saw that right, obviously the how the double bond is there, how it will vary. All you have to understand is that you have to make sure that the carbon atom is tetrahedral if it is sp3 hybridized, obviously, right? That means for each of the carbons I need to have 4 bonds, right? If you can remember this alone, whether I have a double bond, triple bond, a functional group, whatever it is, this part, one point, if you remember that carbon atom should have 4 bonds, each of the carbon atom, then everything is satisfied, right? Now we talked about hybridization also, right? Now hybridization, I asked you to remember a quick trick, right? If there are no pi bonds for a particular carbon, that carbon would be sp3 hybridized. And if there is a carbon which is having only one pi bond, it is involved in only one pi bond, then it will become sp2. And if at all I have 2 pi bonds involved in a particular carbon, then is going to become sp hybridized. Then we saw some questions also, right? And then we went on to IUPAC naming, right? Now, the first point in IUPAC naming is this: identifying the longest possible chain. And one more point, what you have to understand is this longest possible chain should include the most prioritized functional group, right? This should include the most prioritized functional group. If there is only one functional group, there's no problem. Then that is the most prioritized functional group. But if you have more than one functional group, that is where the priority comes into the picture. That we'll see today. How, like, what is the priority order, right? Now, once you get that done, obviously this is what is called as main chain. The longest possible chain is what is called as the main chain, right? Now, I told you that an IUPAC name consists of 3 parts, right? One is what is called as prefix. The other one is the root word. The third one is there is something called a suffix. Again, suffix, they can have primary and secondary suffix, right? Now, when you do the first point properly, that is, if you identify the longest possible chain, one of the part is done, right? And we all know if I have only one carbon in the main chain, med, so on and so forth until dec, right? At least till decane or dec, you should remember. If I have 10 carbon in the main chain, obviously it is going to be dec, and all the others follow, right? Now, what are you going to do about the suffix and prefix, right? Now, I told you suffix comes from the most prioritized functional group, right? Suffix comes from most prioritized functional group, right? So now, if I have only one functional group, there's no problem. But if I have more than one functional group, the most prioritized functional group will give me a suffix, right? And whatever is remaining, right? Whatever is remaining are going to come under the prefix part, right? Whatever is remaining functional which are less prioritized, those are going to come under the prefix part, right? Okay. Now, prefix part. When you come to the prefix part, right, obviously you'll talk about the alkyl branches. I told you, like something like this. If you have CH3, CH, CH3, and one more CH3, if you have, say this is the main chain, right? This is the main chain having three, so it is obviously going to be pro, right? That is okay, right? And you see this carbon atom is not included in the main chain, so this has to come as a branch, and this has to come as a prefix part. That is one thing you have to understand. And the second thing was already we discussed, the less prioritized functional group should also come into the prefix part, right? The less prioritized functional group will also come in the prefix part, because the most prioritized one will go to the suffix, the last part, right? Okay. So now what we will do is, this is what we stopped last class, right? Did we see anything else? No, right? So what we will do today is, right, what we will do today is first understand the priority order, right? Now understanding priority order, after that we'll go for suffix and prefix for all functional groups. Okay, for all the functional group there'll be certain prefixes, there'll be certain suffixes, all those things we'll try to understand. Okay, now talking about the priority order. Okay, now guys, the least priority goes to alkanes, right? The least priority goes to, or I would say the least priority goes to alkyl groups, right? The least priority goes to alkyl groups. Okay, then comes halogens, X, right? These can be, okay, again under halogens I can have different halogens, right? 4 halogens are there: fluorine, bromine, fluorine, bromine, chlorine, and iodine, right? So now let me write it like this. Instead of writing just X, I will give you the priority order with, I mean, for all the, hey, what is wrong? Okay, right. So after alkyl groups comes your F. Okay, then comes Cl, then comes Br, then comes iodine. Okay, right? Fine. Next comes C triple bond C. Okay, next comes C triple bond C. After that comes C double bond C, right? Then comes OH. Then comes CHO, that is aldehyde, right? Then comes your ketone. No. Aldehydes have more priority. Okay, let me write this ulta. Right. So first would be ketones. Then comes your aldehydes. That is your CHOs. Right. This is going to be C double bond O, R and R. Right. Anyways, we'll go into the details later. And at last, you can have acids, that is COOH. Okay, that is COOH. And where will amine come? Amine will come before ketones. Okay, before, after alcohols you will have NH2 also, right? Before ketones, after alcohol you will have NH2 also. Right, now this priority order, guys, let me make it small for you so that I'll be able to see everything. Right, now this is the priority order. Right, now there are some reasons to this there, but there is no one reason. One reason would be the molecular mass, right? You can understand that the atomic masses of iodine is greater, so it is having more priority. F is lesser, so it is having lesser priority. But that is not the only thing, right? You do not remember the logic behind this. All you have to understand is the priority order, right? This is very, 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 very important. Okay, this you have to know, right? Once you know this, right, then we can go to the second point in your IUPAC naming, right? Anyways, before that, we'll try to finish this part also. What are the suffixes and what are the prefixes for all the functional groups, right? So now let me make a table. Functional groups, suffix, okay, prefix, let me tell first, then your suffix, okay, right.
Sir, could you repeat what is ketone again?
What is?
Ketone.
Oh, no, it's very simple. Say both aldehyde and ketone have this C double bond O. Okay, both aldehyde and ketone have this C double bond O. If I have one H and other carbon, right, it can be anything. This carbon again can be big, right? So the moment you see a H, it becomes an aldehyde, right? But if you see there's a C double bond C and both sides carbon atoms are attached, right? That becomes a ketone. Okay, that is the basic difference between aldehyde and ketone. Aldehyde has at least one hydrogen attached to C double bond O, right? But C double, when I have a C double bond attached to two sides carbon, then it becomes a ketone, right? Okay. Now, starting with this, normal, if I have alkanes, right? If I have alkanes, what should be the prefix? What should be the suffix? Right? Now, suffix is very simple, people. You are going to end with ane, in, right? And the prefix part, whenever you talk about the branches, right? I can have alkanes as branches of CH3, C2H5, and all that. Now, for that, you will give alkyl. That means if you have only one carbon atom, then you will give methyl. If you have two, you will give ethyl, like that. Three means propyl. That is how you should give the names. Okay, fine. Next, when I go to alkenes, right? Alkenes, that is C double bond Cs if you have, right? Now, if you have only this, obviously, right? If you have only this, right? This is the maximum priority in the molecule. If it is like that, then you will end up with ene. You'll end up with ene suffix, right? And if you're going to consider them as branches, you will write alkenyl. Alkyl, alkenyl. Alkenyl is for alkene, C double bond Cs as branches, right? Then alkynes, that is C triple bond Cs, right? Now it's very simple. The suffix is simple, "-ine", right? And if it is going to be prefix, I'll write alkynyl. Instead of E, you put a Y. Alkynyl. Right. Moving on. Okay. Then comes your halogens. That is, I'll just write X. And X can be F, Cl, Br, and I. Okay. Now the thing is, people, they do not have any suffix. No suffix. Right? The moment you see that there is a chlorine or a halogen or whatever it is, you will give them only the prefix. Right? Say now, for example, I have CH3Cl, for example, if I have. Like, okay, let me tell you, the prefix part is halo. Halo means fluoro, chloro, bromo, iodo, something like that. Right? Now you have only one carbon and there is a chlorine. Now I told you there is no suffix, right? Now the name of this compound will become, now you see I'm writing chloro first, that is my prefix, chloro, and I have only one carbon, so it is going to be meth, right? And there's only alkane, right? There is no double bond, triple bond, no other functional group, so it is going to be basically an alkane, right? So I'm going to call it as chloromethane. One more example I'll give you like this. Say, if I had CH3, CHBr, CH3, right? Now again, you see there is only bromine, no other functional group, but you have to be very careful with the numbering. Here it is second carbon. I'll come back to the numbering later. I'm just telling you an example. So it is going to be 2 bromo, right? The second carbon atom, I have a bromine, and I have 3 carbon atoms, no double bond, no triple bond, nothing, right? So directly it is going to end with ane. Now you see it's ending with ane because it is an alkane. Okay, so now it is going to become 2 bromo. What? 3 carbon atoms means propane. Then the root word is done, right? 3 is prop, and since it is an alkane, it has to end with ane, right? So remember this alone, right? For halogens, there is no suffix, only prefixes are there. If at all I have only halogens, you have to use them as branches only, that is prefix only, right? That's done. Moving on to alcohols, OH, right? Now the suffix is very simple, OL is what you have to end up with. Okay, and if at all there is another functional group which is having more priority than OH, then you will use the OH as the prefix part, and that would be hydroxy. That would be hydroxy. Okay, next. If I go to a ketone we know, right? C double bond O, R and R. R is an alkyl group, carbon atom basically. Okay, so if it is a ketone and only ketone is there, no, I mean, if ketone is the maximum prioritized functional group, then you will end up with one, O-N-E, right? And if you find that there is another functional group which is having more priority than ketone, then you will use oxo, right? Or you can use keto, right? Or you can use alkanoil. Okay, alkanoil. Don't worry about this. When you go to examples, you'll understand where to use what. Okay, don't worry about this. Okay, so let me clear this part now so that we'll try to finish this. Okay, next. Ketone is over. Then say aldehydes, that is CHO. Hope you know how the CHO looks. CH, and there is one more. It can be anything. It can be carbon. It is generally carbon, right? So now if you have this thing, it has to end with AL. Suffix part is AL, right? That, for example, if you have say CH3CHO, now I see that there are 2 carbon atoms, so eth, right? And I have ethanol AL. See, you are ending with AL here. Okay, don't worry. We'll see a lot of examples. Don't worry at all. So you have the CHO. It has to end with AL. And if at all you have to use, the prefix, very rarely you will use. But if at all you have to use, you will use methanol. Okay, if you will use methanol, right? You can ask me, sir, alkanoil, methanol looks similar, right? But the thing is, here you will always have only one carbon atom, right? Only one carbon atom is there, so we use the term meth, right? But ketones, I know definitely there'll be more than one carbon atom, right? That is why we generally say alkanoil, but it cannot be methanol. If it becomes methanol, it becomes an aldehyde, right? Anything other than methanol, ethanol, propanol, butanol, whatever, those comes under ketone prefix part. Okay, moving on. If you have NH2, right? Now NH2, it can be prefix part is amino, right? And if it is going to be suffix, if that's the only thing, we'll write amine directly, right? Okay. Now there's only one thing left, and that's your acid. Right, so acid, if you have a COOH, okay, COOH is like this, right? Now remember that there is no prefix. Can someone tell me why is there no prefix here? Okay, I'm going to give you the suffix. Suffix is oic acid. Okay, can someone tell me why is there no prefix part?
Oh, sir,
So
it's the
because it
most
is the
priority.
highest priority.
Exactly, right? That is because it is having the highest priority. Even if I have 100 functional group, That is going to have the maximum priority. So that is the one which will decide the suffix, no matter what.
Sir,
That is why we don't have a prefix. Yes, go on.
sir, what is NH2 again? Amides or amines?
Okay, amine is NH2. Amide is C double bond O NH2. Okay, now, I
Okay,
mean,
sir.
there's no bond here. Okay, this is amide. Now, don't worry about amides and all. Right? Don't worry about amides. They will not ask you any questions based on amides' naming and all. Okay, at least not for NCERT, not for CBSE. Don't worry about it. Okay, fine. These are the main functional groups which you have to know. Okay, right? And you have to remember two things. You have to by heart two things. One is the priority order, and next one is this table which I've given you.
Sir?
Yeah, go on.
Sir, halogens doesn't have a suffix.
Yeah, halogen doesn't have a suffix is because IUPAC said it like that. There is no reason behind this. Okay, just to avoid some confusion, right? IUPAC said that no halogens, even though they are a little more prioritized than alkanes. Oh, I'm so sorry. Okay, so even though they are a little more prioritized than alkanes, right? But still, like just to avoid confusion, they said no, you don't have to use any suffix. It's just only prefixes there. Don't worry about it. Here, there is no logical reason. The logical reason is to avoid confusion. IUPAC said it like that.
Okay, sir.
Okay, right, fine. Now these two things we know, right? Now we can go to the second point of your IUPAC naming rules. First point we know, longest possible chain.
Sir.
Yeah.
Sir, could you just show the table for 1 minute?
So can I just show what?
The table, sir.
Yeah. Wait, I'll make it small for you so that everything is visible. Yeah, I think everything is visible, right? Yeah. You can copy it. Maybe I'll give you a minute. Everybody, please copy this. And obviously the priority order also you have to copy. I hope you have copied it. Guys, I already told you that for this chapter, taking notes is, I don't know, it's beyond words important. Okay, it is very important taking notes. So please take down notes. Whatever comes out of my mouth, please try to record it. Like mostly, I will be writing also whatever I'm saying, right? Even if I don't write, you record it, please. Okay.
Sir, for ketone, what is the third prefix?
Alkanoyl. 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 Okay, everybody copied? Can I move on?
So if you are naming a compound, like if ketone is there, so can we use any of the three prefixes or?
No. We'll see where to use what. Oxo and keto are same, right? But alkanoyl will be little different, right? Where to use it
Okay,
will
sir.
see. Okay, oxo and keto are very similar, like not similar, they're exactly same. There is two different names, but alkanoyl you have to use in a certain case. I'll tell you when to use that.
Okay,
Don't
sir.
worry. Okay, right. Any other questions anybody has? Can I move on? Is everybody copied? Can I move on to the next part?
Yes, sir.
Okay, cool. Now we have understood the first point. Done, right? The longest possible chain is the first thing you have to understand, right? Now, second point is number the carbon atoms in the longest possible chain only in the main chain. I'll call it as main chain. Main chain only, right? You should not number the carbon atoms that are there in the branches. No, right? Once you identify the longest possible chain, you are going to number the carbon atoms 1, 2, 3, 4, 5, whatever it is, right? And you cannot just randomly do it, right? You are going to number the carbon atoms in the main chain only such that, right, the most prioritized functional group gets the lowest possible number. Okay, the most prioritized functional group is having the lowest possible number. This is how you must number the carbon atoms. Okay, right. We will take some examples like this. Say, for example, if I have, right, please everybody draw the structure and give numbers. First, you do the first point, right? Identify the longest possible chain, right? And do the second point also, right? And just keep it with you. I'll give you a minute's time. You don't have to name the compound, nothing. Just identify the longest possible chain and give numbers to the carbon atoms that are there only in the longest possible chain. If there is any branch, do not give any number to that. Okay, and keeping this in mind, how you have to number? You have to make sure that the most prioritized functional group gets the lowest possible number. I'll give you 30 more seconds. Quickly do it. Okay, I hope you've done it. I'm going to do now, I'm going to ask you whether it's correct or wrong. You tell me. The correct numbering is 1, 2, 3, 4. Correct or true or false? The correct numbering which I've done like this 1, 2, 3, 4, is it correct or not?
It's correct, sir.
Okay, let us take a vote. I want everybody to go to the chat box and tell me whether it's correct or not correct. Correct means yes, not correct means no. Go for it. Put it in the chat box. Everybody should participate. Where is the... Oh, okay. Like if I have to see the chat box, I have to go into this. Oh, okay. Because I'm using the web, this thing. I don't know what is happening. Okay, anyways, I'll look into here. Okay, Srigarita says no. Strayan says yes. Come on, everybody, participate. Just tell me yes or no.
Sir, could you show the structure again?
I must show. That's the problem, right? Like 1 second. Let me show you again. Yeah, this is the numbering 1, 2, 3, 4, which I have done. Okay, you have seen it. 5 more seconds, you see. Then I'll go to the thing and I'll look at the chat box. Until that time, you can put your answers. I'll check. Yes or no. Correct means yes. No means no, not correct. Okay. Okay. Sri Giridhar says no, and rest all of you are saying yes. Right. What do you think? Should we go with the majority, or should we go with the lone person saying no? What do you think? So people.
Sir,
here,
there is no double or triple bond, so that's why.
Okay, so
That's why I think it's correct.
Sir, I thought it was no, because there's CL in the other branch.
that CL?
In the other branch, sir. So I thought that's the
Sir,
correct one.
could you show the structure once again?
Right, now if you look at this people,
Sir, I
see,
think no, sir.
yeah, it is not correct, right? So the thing is, when you identify the longest possible chain, this itself, the first point itself is wrong. You did not identify the longest possible chain. Yeah, here I have 4 carbon atoms. Maximum is 4 only, but longest possible chain should contain what? Longest possible chain should contain
Functional group.
Functional group.
functional group. Exactly. You should make sure that here I have only chlorine and the hydrocarbons, that is alkane and the chlorine only is there. Out of them, the most priority goes to chlorine. You have to, must make sure that you are including that chlorine, or say at least the carbon having the chlorine, in the main chain. Right? So this is absolute crap. Right? This is not the way you number. Right? What you should do, you should make sure that this is the carbon atom having the functional group, that is the most prioritized functional group, and you are going to make sure that particular carbon atom has the smallest possible number. So I will start from here: 1, 2, 3, 4. This is the correct way of numbering. Right? Say the same compound, I would have written 1, 2, 3, 4, 1, 2, 3, 4. If I have written like this, then you wouldn't have had any confusion. Basically, I have a methyl group here. Right? If I have written it like this, then you wouldn't have had any confusion, right? Right? Obviously, you would have started numbering here: 1, 2, 3, 4. Right? However I give the compound, however I give, you have to make sure that you have to find the longest possible chain. But in that longest possible chain, make sure that the carbon atom having the functional group, at least the maximum priorized functional group, should be there in the main chain. Right? So this is the correct way of numbering. I mean, say this is the correct way of numbering. These are same compound, just that I've written the bonds differently. That's it. Right? So is it, do you not think that this is CH3, right? This is CH3, and that CH3 only I wrote it as a branch. Basically, now if you go like this, obviously this becomes a branch, and that is exactly what I've done here. Okay, right. Now another example I'll give you. In a moment. Right. So if I give you another example. Okay, fine. Do the numbering. I'll give you 10 seconds. Do the numbering. Now see, I have two functional groups, people. One is a double bond and a triple bond. Both of them are there. And you must know the priority order. Only then you will be able to number it. Okay. So now the numbering is like this: 1, 2, 3, 4, 5. Correct or not correct?
Not correct, sir.
Not correct, sir.
Why? Why?
Because the most prioritized is double bond, sir.
Exactly. Right. So you have to make sure that the double bond carbon should have the lowest possible number, because that is having maximum priority. So we will number like this: 1, 2, 3, 4, 5. This is how we number it. Okay, I hope you understand what we are trying to do. Right? First thing is longest possible chain, and you have to include the maximum priorized functional group. Second, once you number the carbon atoms, you have to make sure that the maximum priorized functional group gets the lowest possible number. Okay, right. Let me give you one more example and we'll move on. Okay. What if I give you a cyclic structure? Okay, this is not very tricky. Okay, it's not tricky, but anyways, do the numbering. I have a 6-membered ring, and I have a double bond, and I have a OH. No, wait. I'll make it little more. I am having OH here. Yeah, now you do. Actually, fine. Okay, you do this. Oh, I'm so sorry, guys. I have to change this because this becomes a little easy. I want to make it a little tough. Let me put iodine here, and let me put chlorine here. Now you do it. Yeah, this is the question. Final question. Now number. I'll give you 10 seconds. Okay, I hope the numbering is done. Right, the numbering is like this: 1, 2, 3, 4, 5, 6. Correct? Not correct?
Not
Not
correct,
correct,
sir.
Okay, fine. So it is not correct, obviously. Right. Where should I start the numbering from?
From 3,
Tell me.
sir.
Okay, if I just tell you, like, you can just talk about the functional group and tell me where should I start the numbering from?
From the double bond, top of the double bond.
Good. Right, because when I compare chlorine and iodine and the double bond, obviously the maximum priority goes to double bond. Right. Okay. So either I have to start from. Oops. Okay. So either I have to start from this particular carbon or I have to start from this carbon. Okay. Now please understand, people. Now when you have a double bond in the ring, right? Double bond here, it's no problem. You will eventually go through the double bond. Right. Now how you do, if you put 2 here, anyways, I don't want to confuse you. So the thing is, when you have a double bond in a ring, right, you must remember that the double bond must be traveled. So what I'm trying to say is, if you make one here, for example, right, if you make one here, you cannot put 2 here. This is absolutely wrong. You have to travel the double bond. You can put 2 here only. Or if I put 1 here, you cannot put 2 here. No, you have to put 2 here only. You have to travel the double bond. Okay, you cannot put 1 and the next carbon just here, we don't put 2. Once you travel a double bond, it has to be traveled fully. Okay, so now we understood that either I have to start with either of the double bond of having the carbon double bond. Okay, now how will you do this? Now if you put, say for example, if I put 1, 2, 3, 3, 4, 5, 6. This is one way of doing it. Okay, now the other way, let me draw structure again. Right, I have a double bond here, iodine or chlorine here, and an iodine here. Now the other possibility is I started from here: 1, 2, 3, 4, 5, 6. Out of these two, which is correct? Say this is structure
first
1,
one,
this
sir.
is 1, 2. Okay, someone is telling first is correct. Why?
First one, sir.
Why?
Because iodine is more prioritized than chlorine.
Correct. Right, guys. Now, what you have to understand is the most prioritized functional group. Okay, fine. It is close. It is double bond. Right. Now, when you have other functional groups, still the priority matters. Right. Once you have given the maximum priority, lowest possible number, the next priority should also get the lowest possible number. Again, the next priority should get the low. Like that, you have to do. Right, once you are done with your maximum priority, you should not leave the priority. That's what I'm trying to say. Right, now if you look at here, if I put 1, 2, 3, I know iodine is having more priority than chlorine. Hope you all remember, iodine is having more priority than chlorine. Now you see, here I have 3 and here I have 6 for iodine. That is absolutely wrong. I have to get the lowest possible number for the more prioritized group, irrespective of whether it is maximum priority or lesser priority. Obviously the maximum priority, you will get it done. But look at the less prioritized ones. Among the less prioritized ones, the most prioritized one should get the lowest possible. Okay, among the lower prioritized one, the higher priority should get the lowest possible number. All these things you have to make sure. Okay, right. And second, one more important thing is this particular thing. You should not forget this. When you have a ring structure, you must make sure that you're traveling the double bond. You cannot put 1 and 2 here, as I told you. You cannot put 1 here and 2 here. No. Once you put 1, the second carbon atom having the double bond should be traveled. Only then you can do the priorities, whatever it is. Okay, I hope I made my point very clear. One last example. Say, okay. So if I have this compound with me, do the numbering. Both these are CHOs. Okay, this is one CHO, another CHO. There are only two choices to go on. Right. Okay. So if you have done the numbering like this, 1, 2, 3, 4, 5, then you are correct. Right. Now please understand the maximum priority goes to aldehyde. There are two aldehydes here. Say however you do it, either you start from this side and go this side, or whether you start from this side and go this side. For aldehyde, you are going to get 1 and 5. Is it not? First carbon atom and the last carbon atom, 1 and 5. Right. Now the first priority is done. Now you have to look at what else is there. I have a double bond that is having higher priority. Right. So you have to make sure that that also gets the lowest possible number. If you start from here 1, 2, 3, I'm getting 3. Right. But if I start from here 1, 2, I'm getting 2 itself, I'm getting a double bond. So this is the correct way of doing it. Okay. I hope everybody gets it. Right. However I twist the question, however I twist the compound, you must be very careful. Okay. Right. So the second point is sorted. First and second points are sorted, right? Now the longest possible chain and the numbering of carbon atoms are sorted. Now the third point is when you talk about the prefixes, right? When more than one prefix is there, right? When more than one prefix is there, you have to write the prefixes in their alphabetical order, right? In their alphabetical order. For example, now in this question, we wrote the numbering, right? In this question, the cyclic structure question, obviously I'll have two prefixes, right? One is for iodine, one is for chlorine. You have to have two prefixes, right? Now, which should come first? Chloro should come first because alphabetically chloro comes first, then comes this. So I'll write like this. I'll write 6-chloro. I don't have space. You should write continuously, but I don't have space. I'm writing like this. 3-iodo, cyclo, hex, 1-E. This is, so forget about all these things. Okay. So all you have to understand is this now. Right. Now it's not about priority now. Please understand. Please do not confuse priority with this. Okay. Priority is only for numbering and the suffix part. Okay. Now when you are going to write the prefix part, once everything is done, the numbering is done, everything is done. When you have more than one prefix, all you have to do is follow alphabetical order. Okay. All you have to follow is alphabetical order. Okay. Right. Fine. Now, I already told you this point. These are the 3 points you have to follow. Okay, there's nothing much complicating here. Only these 3 points, if you do properly, you are going to get the answers very simple, right? And other than this, there are few points to be noted, right? Whether it's a prefix or a suffix, right? I told you 3 things. 3 information is must. 3 of the informations are must. 1, where. Basically, that talks about the number. Which number? I told about, see, where is this? Chloro is there, it is in 6th position. Iodo is there, it's in 3rd position. Right? So now where, what, right? What means which is the functional group? Right? Whether it's chloro, bromo, iodo, or say alkene or alkyne, what? Third thing is how many. Right? Now for how many, if you have only one, no, don't specify anything. But if you have 2 such groups, then you will use di. If you have 3, you will use tri, like so on and so forth. If you have 4, you will write quad, tetra. Right? So like this will go. Now more than 4 and all you'll not have, don't worry. Okay, this di and tri at least 90%, so many times you'll be using. Di definitely you'll use so many times. Okay, so these 3 things should be answered. Whether you talk about a prefix or whether you talk about a suffix, all of them should be there. Suffix also where it is mentioned. See, you see the suffix part, right? Here I know the suffix part is "-ine", right? I'm writing 1. See, it's in the first position, right? That's why I write 1. If it was in second position, then I would have written 2 or 3 or 4, whatever it is, depending on what you're going to get. Okay. And one more thing is, guys, I can include this also, right? When you have normal alkanes, normally you would write in. If you have cycloalkanes or cycloalkenes, you have to just include the term cyclo before that. Okay, just you see, normally everything is same, right? For this compound, everything whatever I do for a normal compound is exactly same, except that I include this term cyclo. That's it. Okay, this alone you take care. So these are the small points you have to take care.
Sir,
Okay, yeah, go on.
sir, what was the what part, sir?
Oh, what part is functional group? What
Okay,
functional
sir.
group are you talking about? Okay, what is the functional group? Where is the functional group? How many functional groups? All these things should be answered. Okay, and one last thing I have to know before we go on to full on examples, right? We talked about something called as secondary suffix, right? Is it not? Primary suffix is okay, very simple, right? Now, guys, secondary suffix will come only when I have say, okay, I have alkane plus other functional group, or an alkene plus a functional group, or an alkyne plus a functional group. And basically, when you have functional group, all these things are possible. Right? Now, what are the secondary suffixes? If you find that there are only single bonds, right? CC single bonds are only there, and there is some functional group somewhere. Right? Now, please understand that the secondary suffix you will use is AN. I'll give you examples, don't worry. Okay, so you have to use an as the secondary suffix. Basically, primary suffix will come at the last. Before the primary suffix, you will write this an. Don't worry, we will see some examples. Do not worry. Okay, now if it is an alkene, when you have a C double bond C and have to have a functional group, not in the same carbon atom, say somewhere away, whatever it is, but the moment I see a double bond and there is a functional group, then the secondary suffix you will use is not ENE, it is EN. Okay, and same way for if you have a triple bond, C triple bond C, and there is a functional group, you will use YN as the secondary suffix. Okay, and please understand here also you obviously where, what, how many again is very important. Right? Now here also is very obviously what depends on these three. Either it's an alkane, alkene, or alkyne. Where obviously which number, where exactly is the double bond, where exactly is the triple bond, and how many means how many double bonds you have, how many triple bonds you have. All these things must be entered, must be accounted for when you write the name. Okay. Now if I
sir?
give you very yeah, go on.
Could you repeat all the secondary suffixes?
1 second. Right? If I give you an example, then everything is very understood. Like look at this. Right? Say if I have CH3, CH2, OH. Now let me write CH2 double bond CH, OH, CH triple bond COH. Okay, I have all these three. All of them are going to end with all. Right? All of them are going to end with all because that is the maximum priorized functional group. OH in all these cases is a maximum priorized functional group, so it has to end with OL. And obviously, you will start numbering from this carbon atom only, which is having the functional group 1, 2, 1, 2, 1, 2. Okay, now if I write the name of this compound, first thing is look for any prefix part. There is no prefix, right? There is only one functional group, and that is the maximum priorized one. There is no prefix in this question, right? 1 second, guys. I have to mute myself. Right. So I see a new name, Nitin Anand. Are you new, Kana? One second. I'm so okay. I'm so sorry, guys. So yeah, Nitin, are you new? Are you there, Nitin? Any problem? Maybe he's typing. I don't know. Or is it someone's father's name who joined like this? I don't know, whomever it is. Is it a new student, Nitin? Anybody knows, guys? I'm seeing two Nitin Anands. Nitin Anand first, and then I have another. Okay, fine. I think some problem is there. Okay, sir, you're a new student. Okay, okay, Nitin. Right, some other day, maybe next class, you introduce yourself to me. Right, I didn't see it. Okay, let me share my screen. Oh, already screen is shared only. Shared only. Okay. So yeah, talking about the secondary suffix, right? Now, how will I write the name? First, you are going to end with OL, and obviously here it is one OL because in the first carbon atom I have OL. You have to remember that I have to answer three questions: what, where, and how many. There's only one, right? Okay, no problem. Fine. So now in the first carbon atom I have OL. Now you see there are no double bonds or triple bonds, there are only single bonds, right? So first we'll write your root word. Root word is F because I have only two carbon atoms and there are no double bonds. So I will write the secondary suffix as AN. Okay, right? Now if you go to this one, you can understand ethan or null. Even if you don't mention this one, it's okay. One is understood. One is by default. If you don't mention anything, by default it is one. Okay, now if you look at this one, again it is eth and it is all and it is one all, no doubt, right? One all is what I have. But you see in the first carbon atom, there are first two carbon atoms are there, but I have to take the lowest possible number. In the first carbon atom I have a double bond. I'll write like this: eth one n one all. Now you see this en comes for the double bond. This en comes for the double bond. Okay, same way, this would have been eth one ein one all. Hope you're all able to get it. right? In the first carbon atom, I have a double bond, so I put 1N, right? If I can make it little more easy for you, if you look at it like this, say if I had CH2 double bond COH and say C H double bond
Sir,
CHOH. Yeah, go on.
sir, in the first one, anyways, OH is going to be either in the like only in the terminals, right? So can't we
Yeah,
directly write ethanol or ethanol?
yeah, that's what, in this case you don't have to specify this. Even if you write ethanol, it's okay, it's correct. Even in all these cases, you don't have to mention this one. You can directly write. You can write eth and all, because again you're not mentioning any number here because already it's mentioned, because it's one. That's why you're mentioning. But if you look at this example, you'll need to be very, very clear. Okay, right. Now you have to first identify the longest possible chain. The longest possible chain is this, right? 4 carbon atoms are only there in this chain, right? And both the OH groups are included. The carbon atom is having this OH. This carbon atom is having this OH. Okay, right. So now you have to number the carbon atom such that the most prioritized functional group is OH only, right? So I will start numbering from here. 1, 2, 3, 4. You are getting for both the OH, you're getting 1 and 3, right? But if you would have gone like this side, 1, 2, 3, 4, what are you getting? You're getting 2 and 4, which is not correct. Okay, you have to get 1 and 3, which is the lowest possible number. So this is not correct. I hope everybody gets this. Okay, now once you're done, now let me write the root word very easily. Root word is bute. Okay, now you see that there is a double bond, right? There is a double bond. So obviously I have to use N. En I have to use, but you have to understand that how many are there? There are 2 double bonds, so you will use di-N. Okay, let me write like this: bute di-N. Now obviously before you have to specify the number where now the double bond present. In the first position and in the third position you have a double bond, right? You will write bute hyphen 1 comma 3 di-N. Done. This is your secondary suffix. Sorry, secondary suffix. Now once you are done with this, then put a hyphen, right? I have two OH groups in the first and third position. So I'll write 1 comma 3 in the first and third position. I have 2 OH, so you will write di all, and this is my primary suffix. Okay, so bute because there are 4 carbon atoms, 1 comma 3 di-N because in 1 and 3 I have a double bond. This is my secondary suffix, and in 1 and 3 I have OH, so I write diol and 1 and 3. All the things are included C. Okay, so that is what you have to do with your secondary suffixes. This will happen if I have a single bond, means obviously it is AN. If it is a single bond, obviously if all are single bonds, you really don't have to mention anything. Like what? For every carbon atom, if I have 100 carbon atom, you write 1 comma 2 comma 3 comma 4 comma up to 100 and say 100, whatever the number you have to, the word you have to use. No. Right? Remember that if I have no double bond, triple bond, directly right now, for example, if this was CH3, CH2, 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 OH, and I had said this was also OH, right? Same compound without a double bond, right? How would I have named it? Again, first the root word. There is no prefix here. Please understand, there is no prefix here because that is the maximum prioritized functional group, right? So now bute, right? And I do not have any double bond. You can directly write AN, butane, right? Now in where I have a OH 1 and 3, so I write butane 1 comma 3 diol. Okay, I hope everybody is getting whatever I'm trying to say, right? Is there anybody who has any questions? You will get more. Okay, yeah, you will get more questions as we move on. Any questions are there? Someone is trying to ask something.
So can you give an example where we have both a double bond and triple bond along
Good.
the function?
Coming. We will do an example like that. Right. Say I have we'll have prefix also this time. Okay. Say I have a CHO. I have CH triple double bond CH, and say I have a CH3 here, and say I'll remove another one. I have an iodine here, and say I have C triple bond C, and say I have a C over H here. Okay, right? So all of the, like, I have so many things. I have iodine, I have CH3 as a branch, I have COOH. Oh no, I don't have to use, I don't want to use CHO because it will be a little confusing for now itself. I'll use something else. Okay, say I have CH2OH. Okay, all these things I have. Right now, as you asked, when I have a double and triple bond, how it works, we'll try to see. Okay, fine. Now the maximum priority goes to carboxylic acid. Now see, for CHO and COOH, these are terminal functional groups. What do you mean by terminal functional groups? They can come only at the end. You cannot have, say, CH3, COOH, CH3. This is absolute crap. Right? Why? Because carbon atom will have 5 bonds if you check. Say, look at this. C double bond OH, right? It's done. All the 4 carbon atoms are already done. How will you have one more CH3 like this? This is absolute crap. Right? So like CHO is also same like that. The CHO and COOH are going to be terminal functional groups, right? And you have to start numbering from that carbon only. Right? You cannot start from this carbon because this is a functional group. You start from this carbon. No, you should start from this carbon. Same goes with CHO. Right? These two are the only groups that are like that. Right? Ketone always comes in between. I told you, if there is a ketone, you can tell me, sir, ketone also has a carbon associated with it, but you will see that ketone will always have 2 carbons attached. Right? So it will always come in between only. Right? But this CHO and COOH are going to be terminal functional group. That means they will come only at the ends. Anyways, so now what you have to understand is how to start numbering from here. This is the first carbon. 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms. Right? Now, let me get done with the prefix part first. Right? Now, tell me, for what and all I have to use prefix?
So for
What are the functional groups to which I have to use prefix?
Iodine, sir.
Okay, definitely iodine. Then
alcohol.
this is CH3, okay?
Sure, alcohol and aldehyde.
Alcohol and
Aldehyde.
where is an aldehyde here?
Okay, is that okay? Okay, no, sir. No.
OH is okay, iodine is okay. Then what else?
No, sir, I thought you wrote CH3. I thought it was CH.
Yeah, understood. I understood. So anyways, iodine is okay, OH is okay, and what is the other one? There's one more.
Iodine, sir.
That's done, right? Iodine is done. OH is done. What else is remaining? What else I have to account for? Obviously, the double bond and triple bond will come as
CHO,
secondary
sir.
suffixes.
CHO.
The CH3 as a branch, right? I told you what and all has to be included in the prefix: the lesser prioritized functional groups and alkyl branches. And those also has to be included in the prefix part, right? So these two are lesser prioritized functional groups, and this becomes an alkyl branch. So for you need to have 3 3 prefixes. And remember, since you have more than one type of prefix, you have to follow what? You have to follow, since you have 3 prefixes because of 3 functional groups, what you have to follow?
Alphabetical order.
Alphabetical order. Absolutely. Right. So if I use alphabetical order, first tell me, for OH, what is the prefix? What should I use?
Hydroxy.
Look at hydroxy, right? Good. For iodine is iodo, there's only prefix. For this, what will I use? Methyl. Very simple, right? So this is M, this is H. I think I comes first. No, H comes first, right? H, then I, right? So you will write like this, right? Let me make it a little small. Okay, so if I write the name of the compound, I should start with the prefix part. The prefix first is the first one should be H because that is the alphabetically coming first. So it is 7 hydroxy. Okay, then comes I think I, right? So then it should be 4 iodo, right? Then I have the methyl part that comes again in the 4th carbon atom, no issue. So 4 methyl, right? Now done. That's about the prefix part. Then you can directly write the root word. Root word, I know I have 7 carbon atoms, so it is going to be hept. No problem. Okay. Now comes your secondary suffix. Okay, now for secondary suffix also, when you have double bond and triple bond, you have to follow alphabetical order. Remember this. Okay, when you have a double bond and a triple bond, you're going to use En and Yn both, right? You have to make sure that En comes first, then comes Yn, because alphabetically E comes first, right? So if I write that, where do I have the double bond? You should not, I have 6 and 5, obviously I have to take only 5, the lowest number. Okay, so hept, put a hyphen, 5 N, En, right? Then where do I have the triple bond? In second carbon atom. Okay, in the second carbon atom, you see that there is a triple bond. So you'll write 3 Yn, Yn, and obviously this is going to be carboxylic acid. That is the one is going to decide the prefix. So it is going to be oic acid. You can put 1 if you want, but if you don't want, it's okay. Okay, so this is the entire name for this particular compound which I wrote, right? So you saw the combination where I have 1 double bond, 2 double bonds, 2 triple bonds, 1 double bond, 1 triple bond, 2 triple bond, 2 double bonds. Anything comes, all you have to do, all you have to modify is in this area. Okay, now let me give you a compound. Let me see you're going to do it, right? What is the time we have? Okay, we have time, right? So let me give you this. Okay, so I have this compound. I'll give you 1 minute's time, right? Give me the name of this compound. Remember, for prefix, suffix, secondary suffix, for everything, 3 questions. What, where, how many? Let me make it 1 second, guys. 2, 3, 4, 5, 6, 7. Okay. So I had included 1 more CHO also. Okay, go for it. So if anybody is done, you can tell me the name.
Sir, can I tell?
Yeah, go on.
Sir, 3-iodo, 5,6 dimethyl, non 3,5 di-N, 7-ine, 1,9 di-al.
Okay. There's one mistake. There are 2 iodines, right?
3,4 diiodo.
Correct. That's all are correct, right?
Yes, sir.
So please, first is you have to understand where to start the numbering from. You can either start from this carbon or this carbon, right? Now you have to look at the second priority. Second priority is double bond, right? So obviously only when I start from here, this double bond and this double bond will have lesser priority. I mean, lower number, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, right. Now let us do the prefix part first. I have to do prefix for iodines and your CH3s, and the double bond, triple bond are going to come in the secondary suffix, and CHOs are going to come in the primary suffix. Okay, right. So now again alphabetical order. So I think I comes first. So it is going to be 3,4 diiodo, right? And then comes this one, methyl groups, that is 5,6 dimethyl, right? And then comes your root word. Root word is very simple, non, because I have 9 carbon atoms, right? Then comes your secondary suffix. Now in 3, I have a double bond, and also 5, I have a double bond, right? You should not tell 4 and 6. You should tell 3 and 5 because that is the lower possible number. So 3,5 di-N, right? And you see in the 7th carbon atom, I have a triple bond. So it is going to be 7-ine. And then comes the suffix part, primary suffix, that is obviously going to be the aldehyde. So it has to end with Al. And again, you have 1 and 9 having 2 these things. So I will write 1,9 di-al. This is the name of the compound.
Sir.
Right? Yeah, go on.
Sir, here also, as we know that aldehyde always comes in the terminal position, can we just say dial?
But again, yeah, you can tell dial, but it's better to mention these numbers. Okay. Why is it better? Because if I have a I am not going to ask you the answer to this. Okay. If I have a compound like this, complicated, right? Right. If you take this as the main chain, this will be gone. If you take this as the main chain, this will be gone. If you take this as the main chain, this will be gone. Right? So to avoid such confusions, you give the numbers, it's better. Okay, don't worry. Maybe at a point of time, we will answer this question also. How do we name these compounds? Okay, right. Anyways, I hope everybody is following. Everybody is able to get the answer of how this is the name of this particular compound which I wrote here. Okay, right? Fine. Another example. Let me see. Okay. Okay, I have this one. Once you are done, you can tell me the name.
Sir,
Yeah.
sir, is it 2,5 dichloro 6 methyl X 2,4 ene 1,3, 4 triol?
Okay, 1 comma 3 comma this thing triol. Okay, I think it is correct. Okay, let me check. Right now, once you put wherever you put number 1, your problem is sorted. Okay, now I have to make sure that OH gets the maximum priority, right? And the next priority has to go to double bond. This alone, if you understand, everything else is sorted. And third most important point is double bond must be traveled because it is a ring structure. Okay, that confusion you'll have. Right now, let me check. Okay, let me check. If I put 1 here, I have to put 2 here only. Now, why am I putting 1 here? If I put 1 here, right, I am making sure that the double OH is getting my minimum number and the double bond is also getting 1. Let me check other possibility. I don't know whether it's correct. We'll check. Right. So 1, 2, 3, 4, 5, 6. If I have, right, now that is one way of numbering it. The other way of numbering it would be if I put 1 here and I have to put 2 here only, right? 1, 2. So what are the numbers I'm getting for OH? 1, 3, and 4. Right. If I start the numbering from here, 1, and put 2, obviously you have to put 2 here, you cannot put 2 here, right? You have to put 2 here only if you start numbering here, right? 1, 2, 3, 4, 5, 6. I'm getting 1, 4, and 6 for alcohol, right?
Sir.
So definitely, so the other way is only correct, right? This is not correct. That means this, whatever I wrote, is the correct way of numbering.
Sir.
Yeah.
Sir, why can't we write 1 in the bottom and 2 in the left?
1 in the bottom means here 1 and 2.
Yes, sir.
I told you, right? If you, this is a double bond having carbon, right? Once you have a double bond carbon, it has to be traveled. You don't have any choice. If you put 1 here, you have to put 2 here only. You have to travel the double bond. You remember the question which we solved some time back?
Okay, sir, got it.
Understood, right? That's why we are not putting 2. Okay, so this is the correct way of numbering, right? Okay, right. So done. So now we'll get on the prefix part. Prefix, I'm sorry. Oops. Okay, so prefix, one prefix, I mean both these together one prefix, and this is going to be another prefix. Okay, so now alphabetical order, chloro comes first, so it is going to be 2, 5 dichloro, because I have 2 chlorines in 2 and 5 positions, and then comes the methyl group, that is in 6th position. Okay, 6 methyl. Okay, then comes your root word. Root word here is what? Cyclohex, not just hex. Cyclo compound, I asked you to remember, you have to add just cyclo to that, right? Cyclo hex, right? Then comes, there are secondary suffix. Now in the first position, I have a double bond. In the 4th position, I have a double bond. 1, 2, 3, 4. Oh, no, I cannot do that like that. Anyways, so cyclohex 1, 4 di N, and then comes your alcohol. Alcohol, where all is it? 1, 3, and 4, right? So 1, 3, 4 triol. That's it. This would have been the name of this compound. Okay, right? Easy. So what is the time? I think we'll stop with this for today, Kana. Okay. So next class we'll see some more complicated stuff, right? Till then, if you solve as many as questions, okay, get some book or get some internet source. You just get the questions and try to name these compounds. Any compound, whatever you get in hand. You just start with the NCERT first. Okay, start with your NCERT. You just start naming all the compounds, and if you're not able to name anything, just click a picture and send me. I'll be able to help you. Okay, right? So as much as you practice, as good are you going to become better. I mean, as good are you going to become in naming these compounds. Okay, anybody has any specific questions you want to ask? Okay, fine. So if that's the case, yeah, go on.
Sir, I was wondering why OH isn't becoming a prefix, sir.
Why OH is not becoming the prefix?
Yes, sir.
Because that is the maximum priorized functional group here. I have Cl. What are the functional groups you have here? CL is here, double bond is here, CH3 anyways, Julie, that's the least priority, and OH is here. So among the three, obviously OH has a maximum priority. So that only will give me the primary suffix. I told you, primary suffix is given by what? Primary suffix is given by the maximum priorized functional group. And that in this case is OH. Yes?
Okay, sir. Got it.
Right. Okay. Anybody
Sir?
else? Yeah, go on.
Sir, like in double bond, is it like the same in triple bond? Like if we number 1 in one end, we have to number 2 in the other.
Try this. Okay. If I have a cyclopentane ring, can I put a triple bond here? Is it even first possible? Check it out. If you check this carbon, right? First bond, second, third, and fourth. How is it coming like this? One bond, 2, 3, and 4. But triple bond should not be possible. If I take this carbon, what happens? 1, 2, 3, 4. Triple bond is not possible first. Why am I not getting like this? Okay, fine. Let me start like this, okay? Say, I told you this was CH2. This also was. Both are H2s and H2s, right? Okay. Now what you do is, you remove one hydrogen, make a double bond. Okay. Another hydrogen, make a triple bond possible. Yeah, if that's the case, yes, you will whatever the rule you followed for double bond, you will follow it for the triple bond also. Okay, you have to travel the triple bond. Yes, right.
Okay,
but
sir.
But this is not possible, right? Why am I not able to get? Why is it not possible? A cyclic compound with a triple bond is not possible. Okay, why?
Maybe it's theoretically possible, sir.
Sorry, theoretically possible. Okay, let me check this out. Okay, why is it like this? Even though the valencies are getting satisfied. Anyways, let me check it out. Okay, so this particular triple bond, this kind of compounds never exist. Okay, this also doesn't exist. Right, in a cyclohexane ring, you can never have a triple bond. Let me tell you why next class. Okay, any other questions anybody has? Okay, so if that's the case, people, we'll end it right here. Okay, I hope you are following, everybody is following, and everybody is doing good. Right, thank you so much, people. We'll meet again next week. I'm ending the
Thank you,
class.
sir.
Thank you, sir.
Thank you, sir.
Thank you, everybody. Thank you.